September 12th, 1943, 1400 hours, Augusta, Sicily. Lieutenant Commander Giuseppe Fioravanzo stood on the quay watching American welders cut through the side of an Italian cargo vessel that had been scuttled during the Allied invasion 3 months earlier. The ship, the SS Barletta, lay partially submerged, her hull torn open by demolition charges Italian sailors had detonated before abandoning her to prevent capture. Now, American salvage crews were dismantling her systematically, cutting away damaged sections to assess what could be saved and what had to be scrapped. Fioravanzo was 41 years old, a naval architect trained at the prestigious Royal Italian Naval Academy in Livorno. He had spent 18 years designing and overseeing construction of vessels for the Regia Marina at the Cantieri Riuniti dell'Adriatico shipyard in Trieste. He knew ships the way a surgeon knows anatomy, every plate, every rivet, every structural member that gave a hull, its strength and integrity. For 3 generations, his family had built ships using methods perfected over centuries. Riveting. That was how proper ships were constructed. Millions of hot metal pins, each one hammered into place by skilled riveters working in teams of 4. One man heating the rivets in a brazier until they glowed orange, another catching them with tongs and passing them through the hull structure. 2 more riveters, one on each side of the plate, hammering the malleable metal until the head was perfectly round and flush against the steel. 8 days earlier, Italy had signed an armistice with the Allied forces. The announcement came on September 8th over Radio Algiers, catching most Italian military personnel completely off guard. Marshal Pietro Badoglio, the new head of government after Mussolini's arrest in July, declared that Italy would cease hostilities against the United Nations. German forces immediately moved to occupy the country. Admiral Carlo Bergamini, commanding Italy's main battle fleet, received orders to sail from La Spezia to Malta and surrender the ships to Allied control. He never made it. German aircraft intercepted the fleet and sank the battleship Roma with guided bombs. Bergamini died with 1,500 sailors. Fioravanzo had been in Augusta when the armistice was announced. His assignment, ironically, had been to oversee salvage operations on Italian vessels damaged during the Allied Sicily campaign. Now he was working for the Allies, technically a prisoner, though the Americans treated him more like a consultant. They needed engineers who understood Italian ship construction. Fioravanzo needed to avoid being captured by German forces or executed by Italian Social Republic authorities for collaborating with the enemy. So he stayed in Augusta, watched American operations, and tried to understand how his country had ended up on the wrong side of history. The welding fascinated him despite himself. The Americans were using electric arc welding on an industrial scale unlike anything he had seen. In Italian shipyards, welding existed, but only for minor repairs or specialized applications where weight reduction was critical. The prevailing wisdom among Italian naval architects was that riveted construction was superior. Rivets distributed stress across multiple fastening points. They allowed for some flexibility in the hull structure. They could be inspected visually. They had been proven reliable over decades of service. Welding was faster, certainly, but speed meant nothing if the joints failed at sea, or so Fioravanzo had been taught. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But watching the American crews work, Fioravanzo saw something that contradicted everything he believed about proper shipbuilding practice. The speed was extraordinary. A welder could join 2 steel plates in, the time it took a rivet crew to install perhaps 20 rivets. But it was not just speed. It was the entire industrial philosophy. The Americans were not building ships the way Italian or British or German yards built ships. They were manufacturing ships the way automobile factories manufactured cars, prefabricated sections, standardized components, assembly line techniques applied to structures weighing thousands of tons. An American naval officer approached. Lieutenant Commander Robert Hutchins, United States Navy Civil Engineer Corps. Hutchins was responsible for coordinating salvage operations in Augusta Harbor. He spoke adequate Italian, learned during a pre-war posting at the American Embassy in Rome. He and Fioravanzo had developed a working relationship based on mutual professional respect and the practical necessity of clearing wrecked vessels from a harbour that needed to function as a major Allied supply port. Hutchins asked if Fioravanzo would be interested in visiting an American shipyard. Not here in Sicily, but in the United States. There was a program, he explained, to bring foreign technical personnel to American facilities so they could observe industrial methods that might be useful in post-war reconstruction. Italian engineers who cooperated with Allied authorities and demonstrated reliability could be included. The alternative, Hutchins did not need to say explicitly, was less appealing. German forces were hunting Italian officers who refused to join Mussolini's puppet republic. Trials, executions, or simply being sent to labor camps in Germany. Working with the Americans offered protection. Fioravanzo said yes. He had questions about American shipbuilding that he wanted answered. How were they producing vessels so quickly? What welding techniques allowed them to eliminate riveting almost entirely? Why did their ships not crack apart at sea the way engineering theory suggested welded hulls should? And most fundamentally, how had America built a DARS, merchant fleet in 3 years, that exceeded Italy's entire shipbuilding output since unification in 1861, November 3, 1943, 08:30 hours. Richmond, California. Fioravanzo stood at the edge of Kaiser Shipyard, No. 2, watching a Liberty ship take shape on the ways. The vessel, not yet named, was 41% complete. Keel laid October 27th, 7 days ago. In Italian yards, 7 days was barely enough time to prepare the slipway and position the keel blocks. Here, the Americans already had the entire bottom shell in place, stem and stern frames erected, and were installing the deck structure. The journey from Sicily had taken 3 weeks. Military transport from Augusta to Naples. C-47 cargo aircraft from Naples to Casablanca. Another C-47 to the Azores. B-24. Liberator bomber converted for passenger transport from the Azores to Newfoundland. Commercial rail from Newfoundland through Canada to Chicago. Finally, another train from Chicago to Oakland. Fioravanzo had crossed an ocean and a continent to stand here in the California morning watching something that should not be possible. The shipyard covered what Hutchins had told him was about 90 acres, 4 slipways, each capable of launching a 10,000-ton vessel. Cranes everywhere, some fixed to the ground, others moving on rails. Prefabrication sheds where entire sections of hull were assembled before being lifted onto the slips. Warehouses, machine shops, welding shops, administrative buildings, a power plant generating electricity for the entire complex, housing for workers, a cafeteria, medical facilities. This was not a traditional shipyard. This was an industrial factory that happened to produce ships. Hutchins explained the production statistics. Kaiser Richmond No. 2, yard had launched its first Liberty ship in January 1942. Since then, 22 months, they had delivered 93 vessels, roughly 1 ship, every 7 days. The yard employed approximately 25,000 workers, working 3 shifts, 24 hours per day, 7 days per week. About 30% were women. Many workers had never set foot in a shipyard before Pearl Harbor. They came from farms, from service industries, from unemployment lines. Kaiser trained them in weeks, sometimes days, and put them to work building the most complex machines most of them would ever touch. Fioravanzo walked closer to the ship under construction. A welder was joining 2 deck plates, running a bead along the seam where the edges met. The arc was shielded by a pile of granular flux that covered the weld zone. Submerged arc welding, Hutchins called it. The flux protected the molten metal from atmospheric contamination and stabilized the arc. The welder guided an automated carriage that moved along the seam at constant speed, feeding electrode wire continuously into the weld pool. No stopping to change electrodes, no visible arc to strain the eyes. Just steady, continuous, fast metal joining that produced a weld stronger than the base metal it connected. This was what Fioravanzo had come to see. This was the technique that made everything else possible. Without this welding method, American ship production would be impossible. Riveting required skilled workers who took years to train. Welding required less skill and could be learned in a week. Riveting was slow, labor-intensive, required teams of 4 workers per rivet gun. Welding could be done by one person or even automated. Riveting required overlapping plates, which added weight and material. Welding joined plates edge to edge, saving steel. Every advantage favored welding except one. Italian engineers, British engineers, German engineers all believed welded ships would crack. Hutchins took Fioravanzo to the prefabrication sheds. Here, away from the slipway, workers assembled major sections of the ship: a bow unit, a stern unit, engine room sections, deck houses. Each section was built flat on the ground or on elevated platforms, complete with all internal framing, piping, wiring, fittings. When a section was finished, cranes lifted it, sometimes weighing 80 tons or more, and transported it to the slipway where it was lowered into position and welded to adjacent sections. The ship was not built plate by plate, rivet by rivet, like in European yards. It was assembled from large prefabricated modules like a child's building blocks. The time savings were extraordinary. In a traditional yard, workers would install framing inside the hull after the shell plating was complete. Access was difficult. Working conditions were cramped. Each structural member had to be positioned individually, held in place, and riveted. Progress was measured in days or weeks. In Kaiser's yard, entire sections arrived at the slip with all internal structure already installed. What took weeks in Italy took hours in California. Fioravanzo asked about quality. How could the Americans be certain that welded joints would hold? What about brittle fracture, the phenomenon where steel loses ductility at low temperatures and cracks suddenly under stress? What about stress concentration at weld seams? What about inspection? You could see a bad rivet. A defective weld was hidden inside the metal itself. Hutchins was honest. The Americans had experienced problems. Some Liberty ships had developed cracks. A few had broken apart catastrophically. The SS Schenectady had split completely in two while sitting in calm water at the dock in January 1943. One moment an intact vessel, the next moment 2 separate pieces. Investigation found that the steel used had poor notch toughness at low temperatures, and the welded design allowed cracks to propagate unimpeded once they started. In riveted construction, rivets acted as crack arresters. Each rivet hole created a discontinuity that stopped crack propagation. Welded hulls had continuous seams. A crack that started could run the entire length of the ship, but the Americans had adapted. They modified the steel specifications to use higher quality alloys with better low-temperature properties. They added crack arresters, strategic rivet lines at critical locations to stop propagation. They redesigned structural details to reduce stress concentrations. They improved welding procedures and welder training. They instituted inspection protocols, using X-ray radiography to detect internal weld defects. The failures taught them what did not work, and they fixed it. Quickly. The program could not afford to stop. American merchant shipping was being sunk faster than it could be replaced. The production had to continue. Fioravanzo watched workers throughout the day: welders, pipe fitters, electricians, painters, carpenters, labourers. The workforce was remarkably diverse. Women working alongside men, African Americans in positions of responsibility that would be unthinkable in Italy. Young people barely out of high school operating cranes that lifted 80-ton loads. The Americans had mobilized every available person because the alternative was losing the war. At 1500 hours, the welding on the deck stopped. Lunch break. Fioravanzo watched workers file into the cafeteria. Hutchins invited him to join them. The food was abundant: hot meals, fresh vegetables, meat, bread, coffee, desserts. This was a shipyard cafeteria feeding workers during wartime rationing, and the selection exceeded what Fioravanzo could obtain in the best restaurants in Trieste before the war. The contrast was jarring. In Italy, even before the armistice, food had been scarce. Workers received inadequate rations. Black markets flourished. Here, American shipyard workers ate better than Italian naval officers. After lunch, Hutchins showed Fioravanzo the welding school. Kaiser had established training facilities to convert inexperienced workers into productive welders as quickly as possible. The course lasted 1 week for simple welding tasks, 4 weeks for more complex work. Students learned basic electricity, metallurgy, safety procedures, and then practiced running beads on scrap plate until they could produce acceptable welds consistently. Once certified, they were assigned to the shipways. Learn by doing. Production could not wait for years of apprenticeship. Fioravanzo spoke with one of the instructors, a man named Walter Chen, who had been a welder before the war and now taught others. Chen explained the submerged arc process in detail. The method had been developed and patented in the 1930s by the National Tube Company for welding pipe seams. During the war, shipyards adapted it for joining ship plates. The key advantages were speed and consistency. A skilled manual welder using covered electrodes could deposit perhaps 4 pounds of weld metal per hour. Submerged arc welding deposited 30 to 50 pounds per hour. The difference was not incremental. It was transformative. But it was not just the deposition rate. It was the quality of the weld itself. The flux covering prevented atmospheric contamination. Nitrogen and oxygen in the air could embrittle the weld metal, causing cracking and porosity. The flux created a protective envelope, and the resulting weld was denser, stronger, more ductile than manual welds. The heat input was more controlled. Penetration was deeper and more uniform. The mechanical properties were better. Testing showed that properly made submerged arc welds had tensile strength exceeding the base metal. The joint was stronger than the plates it joined. Chen showed Fioravanzo the automatic welding carriage. The device looked simple, almost crude, a frame on wheels with an electric motor, a wire feed mechanism, and flux hopper. Yet this simple machine was producing welds faster than 5 manual welders working simultaneously. The productivity gain was staggering. Kaiser employed perhaps 3,000 welders across all shifts. If submerged arc welding improved their productivity by factor of 5 or more for long seam welds, that was equivalent to having 15,000 additional workers without adding a single person to payroll or providing additional housing or food or transportation. This was the revelation Fioravanzo had come to California to understand. The Americans had not won through superior craftsmanship or engineering elegance. They had won through industrial organization and willingness to adopt any technique, no matter how unconventional, that improved productivity. Traditional European shipbuilding emphasized quality, precision, skilled labor. American shipbuilding emphasized quantity, speed, results. The Liberty ships were not beautiful. They were functional. They were adequate. They were produced at rates that made their individual quality almost irrelevant. If one ship developed cracks, build 2 more to replace it. The economic capacity made perfection unnecessary. As evening approached, Fioravanzo stood again at the edge of the slipway watching the unnamed Liberty ship. In one day, he had observed more welding than he had seen in his entire career in Italian yards. The noise was constant, the blue-white arc flashes illuminating worksites across the yard like fireflies in darkness. Shifts changed, new workers arrived, the work never stopped. 24 hours per day, 7 days per week. The ship would be complete in approximately 38 days from keel laying to launch. Another week for fitting out, installing machinery, sea trials. 45 days total. In Trieste, a comparable vessel would require 8 to 10 months. Hutchins asked what Fioravanzo thought. The Italian engineer chose his words carefully. He said he understood now why Italy had lost the war. Not because Italian sailors lacked courage or Italian engineers lacked competence. Italy lost because the nation had entered a modern, industrialized conflict with pre-industrial methods. Riveting was a 19th century technique. Welding was 20th century. Italy built ships the way craftsmen built cathedrals, slowly, carefully, with attention to tradition and proven methods. America built ships the way factories built automobiles, quickly, systematically, with attention only to results. When production capacity determined victory, the craftsmen would always lose to the factories. That night, Fioravanzo wrote in his journal. He documented everything he had seen: the submerged arc welding equipment, the prefabrication methods, the training programs, the productivity statistics. He wrote these things not for himself, but for whoever would rebuild Italy after the war ended. The knowledge would be valuable. Italy would need to industrialize. The old methods, the traditional techniques his family had practiced for 3 generations, were obsolete. The future belonged to nations that could produce faster, cheaper, more efficiently than their competitors. Craftsmanship would not save Italy. Industrial capacity would. November 9th, 1943. A transport ship left San Francisco Bay, carrying Fioravanzo back toward the Mediterranean. He travelled with a convoy of cargo vessels, the very Liberty ships he had watched being built in Richmond, now loaded with supplies destined for Allied forces in North Africa and Italy. The crossing would take weeks. Fioravanzo spent the time writing a technical report for Italian naval authorities who remained loyal to the king's government. The report detailed American shipbuilding methods with specific emphasis on welding techniques and how they enabled mass production. The report included calculations. Italy's largest shipyard, Cantieri Riuniti dell'Adriatico in Trieste, employed approximately 8,000 workers and produced perhaps 6 to 8 merchant vessels per year using traditional methods. Kaiser Richmond No. 2, employing 25,000 workers, produced 50 vessels per year. The productivity ratio was not proportional to workforce size. American workers were not more skilled. They were organized more effectively. They used better tools. They eliminated unnecessary steps. They focused on speed over perfection. Fioravanzo calculated that if Italian yards adopted American methods, complete conversion to welded construction, prefabrication, assembly line organization, they might triple productivity with existing workforce and facilities. But that assumed Italy had access to the welding equipment, the steel, the electrical power, the trained personnel, the raw materials. In November 1943, Italy had none of those things. The country was occupied, divided, devastated. Industrial capacity that had taken decades to build was being destroyed by Allied bombing and German requisitions. The knowledge Fioravanzo carried would be useless for years, perhaps decades. But he wrote the report anyway. Someone would need it eventually. When the war ended, when reconstruction began, when Italy needed to rebuild not just buildings and bridges but entire industrial systems, the knowledge would matter. The Americans had demonstrated that industrial warfare required industrial production methods. Nations that understood this would prosper. Nations that clung to traditional methods would become historical footnotes. Italy had to choose which future it wanted. December 14th, 1943, 0900 hours. Algiers, French North Africa. Fioravanzo sat across a desk from Commander James Thompson, Allied Naval Technical Intelligence Section. Thompson was responsible for evaluating technical information provided by Italian naval personnel who had sided with the Allies after the armistice. The intelligence value of what defecting Italian officers knew varied considerably. Some had operational knowledge about German forces, others understood Italian naval codes and communications, procedures. Fioravanzo's value was different. He understood shipbuilding. More specifically, he understood what Italian shipbuilding could not do. Thompson asked direct questions. How many ships could Italian yards produce annually at maximum capacity? What were the bottlenecks? What resources were most critical? What would be required to increase output? Fioravanzo answered honestly. Italian shipbuilding capacity, before the war, had been roughly 200,000 tons annually across all yards. That included military vessels, merchant ships, and specialized craft. For comparison, American shipyards were now producing approximately 8 million tons per year. The ratio was 40-1. Italy's entire annual production equaled what American yards completed in less than 2 weeks. The bottleneck was not labor or facilities. Italian yards had skilled workers and adequate infrastructure. The bottleneck was method. Riveting was fundamentally slow. Each rivet required 4 workers, specialized tools, significant time. A large cargo ship might contain 2 to 3 million rivets. Even working efficiently, rivet crews could install perhaps 500 rivets per day. The mathematics dictated construction time. You could not speed up riveting beyond certain limits without compromising quality. Welding eliminated that constraint entirely. A skilled welder could replace what would require dozens of rivets in the time a rivet crew installed one. The productivity difference was not marginal. It was an order of magnitude. Any nation that mastered welding techniques and organized production around them would dominate shipbuilding. America had done this. Britain was adopting similar methods. Germany had used welding selectively, primarily on warships where weight reduction was critical, but never scaled it to merchant vessel production. Italy had barely begun to experiment with welding before the war ended its shipbuilding entirely. Thompson asked about German capabilities. Did Fioravanzo know anything about German shipyard methods? The question was significant. Allied intelligence wanted to understand whether Germany might increase U-boat production to levels that threatened the Atlantic convoy system. Fioravanzo explained what he knew. German yards were technologically advanced. They used welding extensively on submarines and surface warships. But German industrial capacity was limited by resources, particularly steel and electrical power. Allied bombing was systematically destroying German manufacturing infrastructure. Even with superior techniques, Germany could not match Allied production because the factories, power plants, and transportation networks were being eliminated. The conversation turned to post-war reconstruction. Thompson asked whether Italian yards could be restored to production quickly once hostilities ended. Fioravanzo was skeptical. The Germans were systematically stripping Italian industrial facilities of machine, tools, equipment, raw materials. What they could not take, they destroyed. Trieste, where Fioravanzo had worked, was under German occupation. The shipyard was being used to repair German vessels, but Italian workers were being forced to labor under threat of deportation. When the Allies eventually liberated northern Italy, they would find industrial capacity reduced to rubble. But more fundamentally, Italian shipbuilding had been obsolete before the war began. The industry had relied on methods developed in the 19th century: skilled craftsmen, slow construction, high quality, but low quantity. That approach worked when competition was limited and construction time was not critical. In modern warfare, where merchant tonnage determined logistics and logistics determined victory, slow construction was fatal. Italy needed to rebuild its shipbuilding industry from principles up, adopting American techniques, American organization, American industrial philosophy. Traditional methods would condemn Italy to permanent irrelevance. Thompson made notes. He asked if Fioravanzo would be willing to write additional technical reports. The Allied Control Commission would need assessments of Italian industrial facilities once the country was liberated. Engineers who understood both Italian capabilities and American methods would be valuable. Fioravanzo agreed. He had nowhere else to go. Northern Italy was occupied by Germans. The Italian Social Republic, Mussolini's puppet government, had issued arrest warrants for officers who collaborated with the Allies. Staying in Allied territory was not ideological commitment. It was survival. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. March 23rd, 1944, 1400 hours, Naples, Italy. Fioravanzo stood in what remained of the Naples shipyard. Allied bombing had reduced most of the facility to wreckage. Cranes collapsed into twisted metal. Workshop buildings were burned shells. Slipways were cratered. The harbour was choked with sunken vessels. Before the Allies arrived, German forces had executed a systematic demolition program, destroying anything that might be useful to the enemy. Naples, once one of Italy's major ports, was effectively dead. An American naval construction battalion, the Seabees, was working to restore minimum functionality. They were clearing wrecks, repairing quays, rebuilding the most critical infrastructure. The speed impressed Fioravanzo despite the devastation surrounding him. The Seabees worked with the same industrial intensity he had observed in California: heavy equipment, organized crews, 24-hour operations. They were not trying to restore the shipyard to pre-war condition. They were building enough capability to support Allied logistics. Good enough was sufficient. Perfection was irrelevant. A Seabee lieutenant, a civil engineer from Chicago in civilian life, showed Fioravanzo the plans. The Americans intended to construct a temporary pier using prefabricated concrete sections shipped from North Africa. The sections would be floated into position and sunk to form a causeway extending into deep water where Liberty ships could moor and discharge cargo directly. Construction time: 3 weeks. In Italian practice, such a pier would require months of planning, material procurement, skilled labor. The Americans would complete it in less time than Italian engineers would spend on design drawings. The lieutenant explained the American approach to military construction. Speed mattered more than elegance. Functionality mattered more than durability. If a structure lasted long enough to serve its purpose, that was success. If it fell apart after the war ended, that did not matter. Build it fast, use it hard, replace it when necessary. This philosophy horrified traditionally trained engineers. Fioravanzo recognized it as the falters, same philosophy that produced Liberty ships. Adequate performance, maximum speed, overwhelming quantity. The engineering was not sophisticated, it was effective. They walked through the destroyed shipyard. Fioravanzo pointed out where riveting shops had been, where steel storage had been, where the main fabrication hall had stood. All gone. The lieutenant asked if Italian yards had used welding. Fioravanzo said minimally. Some specialized applications, some repair work. But building entire ships by welding? No. Italian naval architects considered it risky, unproven. The British had experimented with welding in World War I, building a ship called the Fulagar with an entirely welded hull. It worked, but the technique never became standard practice. Riveting was trusted, welding was suspicious. The lieutenant shook his head. He said American yards were building 50-ton prefabricated sections that contained hundreds of welds and 0 rivets. These sections were lifted by cranes, positioned within fractions of an inch, and welded to adjacent sections. The entire ship was one continuous welded structure. If Italian engineers considered that risky, they misunderstood the mathematics. A properly made weld was stronger than the base metal. Testing proved it conclusively. The failures that occurred, the ships that cracked, resulted from poor steel quality or design errors, not welding itself. Fix the steel. Fix the design. The welding worked fine. Fioravanzo absorbed this. He was watching his profession being redefined in real time. Everything he had learned, every principle he had been taught, was becoming obsolete. The future of shipbuilding would be welding, prefabrication, mass production. Traditional craftsmen would become historical curiosities. The men who could organize industrial production would dominate. Italy could either adapt to this new reality or accept permanent second-tier status. That evening, Fioravanzo wrote another report. This one focused on reconstruction requirements. To rebuild Italian shipbuilding capacity using modern methods would require extensive welding equipment, electrical power generation far exceeding pre-war capacity, steel of higher quality than Italian mills currently produced, trained personnel in quantities that did not exist, complete reorganization of shipyard layout and workflow, adoption of American prefabrication techniques, abandonment of traditional apprenticeship training in favor of rapid skill development programs. The list was daunting. Every requirement was feasible technically but difficult economically. Welding equipment could be purchased from American manufacturers, power plants could be built, steel mills could be upgraded, workers could be trained, facilities could be redesigned, but all of that required capital, resources, time, and most critically, willingness to abandon traditional methods completely. Half measures would not work. Italian yards could not partially adopt welding while retaining riveting. The techniques required entirely different approaches to construction. Trying to combine them would produce the worst of both worlds. Fioravanzo calculated the investment required to modernize one major Italian shipyard to American standards. The number was staggering, millions of dollars in 1944 currency values, equivalent to the entire pre-war Italian naval construction budget for multiple years. Where would that capital come from? Italy was occupied, divided, bankrupt. The government barely functioned. Industry was destroyed or in German hands. Even after liberation, reconstruction would focus on immediate survival: food, shelter, basic infrastructure. Modernizing shipyards would be low priority. But without modern shipbuilding, Italy would remain dependent on foreign vessels for commerce. Merchant shipping was economic lifeblood for a peninsular nation surrounded by water. If Italy could not build ships competitively, it would buy them from Britain, America, or whoever offered the lowest prices. That meant Italian yards would remain idle, Italian workers unemployed, Italian engineering expertise unused. The choice was stark: modernize or accept irrelevance. July 7th, 1944, 10:00 hours, Rome. The city had been liberated by Allied forces on June 4th. Fioravanzo was assigned to the Allied Control Commission's Industrial Assessment Team. His task was evaluating which Italian manufacturing facilities could be restored to operation and which were beyond practical repair. Most fell into the latter category. German forces had been thorough in their demolitions. What bombing had not destroyed, retreating Wehrmacht units demolished systematically. He met with surviving Italian naval administrators, old colleagues from the Regia Marina who had navigated the complicated political situation after the armistice. Some had sided with the Allies immediately. Others had waited, hoping to avoid commitment until the outcome was certain. A few had collaborated with the Germans and were now in custody, awaiting trial. The distinctions were messy. Everyone had made choices based on incomplete information and uncertainty about survival. Fioravanzo did not judge. He had made his own choice to work with the Allies because the alternative was worse. Others had calculated differently. The conversation turned to shipbuilding's future. The administrators wanted Fioravanzo's assessment based on what he had observed in America. Could Italian yards compete post-war? He was blunt, not using current methods. Italian shipbuilding was technologically 20 years behind American practice. The gap was not incremental, it was fundamental. American yards had reinvented shipbuilding during the war. They had applied mass production principles that transformed the entire industry. Unless Italian yards adopted identical methods, they would be uncompetitive. Ships built in Italy would cost more and take longer than ships built in America or Britain. No ship owner would choose Italian vessels if better alternatives existed at lower prices. One administrator objected. Italian craftsmanship was superior. Italian ships were more elegantly designed, better finished, more durable. Quality mattered. Fioravanzo disagreed sharply. Quality was irrelevant if you could not compete on price and delivery time. A Liberty ship might not be elegant, but it served its purpose adequately and cost half what a traditionally built equivalent cost. Shipowners cared about economics, not elegance. If Italian yards insisted on building ships the old way, they would have no customers. The objection reflected a deeper problem. Italian industry had never fully embraced mass production principles. Manufacturing remained craft-oriented. Skilled workers produced high-quality goods in small quantities at high prices. That worked for luxury products, fashion, automobiles for wealthy buyers, specialized machinery. It did not work for commodity products like merchant ships, where price and availability determined purchasing decisions. To compete, Italy needed to abandon craft traditions and adopt industrial methods. That meant cultural change as much as technical change. Another administrator asked about specifics. What exactly did American yards do differently? Fioravanzo explained in detail. Welding instead of riveting eliminated 2/3 of labor costs and reduced construction time by factor of 4 or 5. Prefabrication of major sections allowed parallel construction rather than sequential. Standardized designs eliminated custom engineering for each vessel. Assembly line workflow moved ships through production systematically. Rapid training programs converted unskilled workers into productive welders in weeks. Every element was designed for maximum speed and minimum cost. The administrator asked if welded ships were reliable. Fioravanzo said yes, with caveats. Early Liberty ships had experienced cracking, problems due to poor steel quality, and stress concentrations at design discontinuities. The Americans had fixed those problems by improving steel specifications and modifying structural details. By mid-1944, Liberty ships were performing reliably in service. Some had been torpedoed, bombed, run aground, subjected to severe weather, and survived. The welded construction proved adequate for purpose. Not perfect, but adequate. That was the standard, good enough to work, cheap enough to produce in quantity. But there was another element the administrator had not asked about: industrial capacity. American shipyards could produce ships quickly not just because of techniques, but because of infrastructure supporting those techniques. Reliable electrical power, high-quality steel in massive quantities, transportation networks that moved materials efficiently, trained workforce in millions, capital for investment. None of those conditions existed in Italy in July 1944. Even if Italian engineers understood American methods perfectly, they could not replicate them without the entire industrial ecosystem that made them possible. This was the lesson Fioravanzo had learned. Shipbuilding was not just about shipyards. It was about everything surrounding shipyards: steel mills, power plants, transportation, education, capital markets, government policy. America dominated shipbuilding because American industry dominated everything. Germany had excellent engineering, but insufficient resources. Britain had adequate resources, but limited labor. Italy had neither sufficient resources nor sufficient labor. No amount of technical knowledge would overcome fundamental economic constraints. The meeting ended without conclusions. The administrators would write reports. The reports would go to politicians who would make decisions based on factors beyond engineering logic. Fioravanzo returned to his temporary office and continued documenting industrial facilities. The work was tedious, but necessary. Someone had to record what existed, what was destroyed, what could be rebuilt, what should be abandoned. The information would matter eventually when reconstruction began in earnest. October 19th, 1944. 1600 hours. Taranto. Fioravanzo inspected the naval base where Italian warships had surrendered to Allied control after the armistice. The battleships Vittorio Veneto and Italia sat at anchor, immobilized, crews reduced to skeleton maintenance parties. These vessels represented the peak of Italian naval engineering: sophisticated designs, powerful armament, high speed, beautiful ships by any measure, and completely irrelevant to the war's outcome. An American naval officer was touring the Italia, examining construction details. Captain Harold Morrison, U.S. Navy Bureau of Ships. Morrison's specialty was battleship design. He was studying Italian construction methods to compare with American practice. Fioravanzo joined him. They walked through the ship, discussing design philosophy. Morrison was impressed by certain aspects. The Italian approach to underwater protection was innovative. The arrangement of machinery spaces was efficient. The fire control systems showed sophisticated engineering, but he identified the fundamental problem immediately. The ship was too lightly built for its size. Italian designers had sacrificed structural strength to achieve high speed and heavy armament within treaty displacement limits. The result was a vessel that performed well in ideal conditions but was vulnerable to damage. More significantly, Morrison noted the construction method, riveted throughout except for a few welded sections in non-critical areas. He asked why. Fioravanzo explained that Italian naval architects considered riveting more reliable for warships. Morrison disagreed. American and British battleships built during the war used welding extensively. The USS Iowa class had welded. hulls with selective riveting only at crack arrestor locations. Welding saved weight, improved strength, reduced construction time. The paranoia about welding was unfounded. Fioravanzo pointed out that Italia had been launched in 1940. Design work had been done in the mid-1930s when welding was less proven. Morrison conceded the point, but noted that German battleships from the same era used welding successfully. The Bismarck's hull was 70% welded. The weight savings allowed Germany to include heavier armour and more powerful machinery within the same displacement. The Germans had understood something Italian designers had not. Welding was the future, regardless of lingering doubts about reliability. They discussed the broader strategic situation. Morrison said the Pacific War was demonstrating that aircraft carriers, not battleships, would dominate future naval warfare. The decisive battles were being fought by carrier task forces launching airstrikes at ranges beyond battleship gun range. Surface engagements between capital ships were becoming rare. The massive investment in battleship construction by Italy, Germany, Japan, even Britain and America was strategic miscalculation. The ships were magnificent but obsolete before completion. Fioravanzo found this analysis depressing but accurate. Italia had cost massive resources to build: materials, labour, time, engineering, expertise. The ship had participated in perhaps 5 significant actions during the entire war and achieved minimal results. German bombs had damaged it severely in 1943. Now it sat immobilized, awaiting final disposition as war reparation. The return on investment was negative. Italy would have been better served building merchant ships or escort vessels, or not building anything and spending resources on ground forces. But the real lesson was about production philosophy. Italia was a masterpiece of individual craftsmanship, every rivet perfect, every plate fitted precisely, every system engineered carefully. Building it had taken 4 years. For comparison, American shipyards were building Essex-class aircraft carriers in less than 2 years, using welding and prefabrication. The carriers were not as elegant as Italia, but they worked, and America was producing them in quantities that overwhelmed Japanese capacity to sink them. Quantity had defeated quality comprehensively. Morrison asked if Italian yards would rebuild after the war. Fioravanzo said, "Probably yes, but not to build warships. The peace terms would restrict Italian naval construction severely. Merchant vessels would be priority. Italy needed merchant tonnage to rebuild commerce. But whether Italian yards could compete with American, British, or potentially Japanese shipbuilding post-war remained uncertain. The gap in productivity was so large that Italian yards might simply be uncompetitive permanently. Morrison suggested that Italian engineers visit American yards during reconstruction period. Learn the techniques, adopt the methods, bring the knowledge back to Italy. The Americans would share technology freely because American industry was confident. They produced so efficiently that foreign competition was not threatening. Teaching others American methods would accelerate global reconstruction, which benefited American interests. Fioravanzo appreciated the offer but recognized the complexity. Technology transfer was possible. Transferring the industrial culture that made the technology effective was harder. America had developed mass production philosophy over decades. Italy would struggle to replicate that culture quickly. January 15th, 1945, 1300 hours, Naples. Fioravanzo stood on the temporary pier the Seabees had constructed. Ships were unloading supplies constantly. American efficiency had transformed Naples from devastated port to functioning logistics hub in less than a year. The contrast with pre-war Italian port operations was stark. Italian ports had been slow, bureaucratic, labor-intensive. American ports were fast, organized, industrial. A Liberty ship was moored at the pier, the SS James Whitcomb Riley. Launched from Richmond in 1943, the same yard Fioravanzo had visited. The ship had crossed the Atlantic 11 times, carrying troops, equipment, food, ammunition. It had survived one submarine attack off Gibraltar, taking a torpedo hit that damaged the bow but did not sink the vessel. Repairs in Casablanca took 3 weeks. The ship returned to service and continued operating. This was the reality of welded construction. Not perfect, but resilient enough for purpose. Fioravanzo examined the torpedo damage repair. American welders had cut away the damaged bow section and welded a new section fabricated in a North African repair facility. The work was crude by Italian standards. The weld beads were visible, unfinished. The paint did not match. But the ship floated. The hull was watertight, and structural strength was adequate. Good enough. The American standard. Do not spend time making it beautiful. Make it work, and move on. The ship's captain, a merchant marine officer named Robert Walsh, invited Fioravanzo aboard. Walsh had been sailing Liberty ships since early 1943. He had opinions about welded construction. It worked, he said simply. He had experienced rough weather, seen seas that would have destroyed lesser vessels, and the Riley had held together. Were Liberty ships as good as traditionally built cargo ships? Probably not. Did that matter? Not really. The ships did their job. They carried cargo from point A to point B. That was success. Walsh mentioned that some Liberty ships had broken apart. Everyone in the merchant marine knew the stories. The Schenectady splitting in half at the dock, the SS John P. Gaines breaking in two in the North Atlantic. Several other complete failures and numerous problems. But Walsh noted that thousands of Liberty ships had been built, and the failure rate was low, perhaps 1%. In traditional construction, you might have 0 failures, but you would build 1/10 as many ships. Better to build 1,000 ships with 10 failures than 100 ships with 0 failures if you needed logistics capacity to win a war. This was the calculus that drove American production. Accept some losses to maximize output. The mathematics favored quantity even with quality compromises. It was a military logistics calculation, not an engineering aesthetics calculation. Engineers wanted perfect designs. Logistics officers wanted adequate designs in maximum numbers. The logistics officers won because they controlled the requirements. Engineers served logistics requirements, not their own standards. Fioravanzo asked Walsh about crew accommodations. Were Liberty ships comfortable? Walsh laughed. Comfortable was not the word he would choose. The ships were functional. Crew quarters were adequate. The food was decent. The working conditions were acceptable. But compared to pre-war passenger liners or well-appointed cargo vessels, Liberty ships were austere. They were built for utility, not comfort. Crews adapted. When you were carrying ammunition to a war zone, you did not complain about the quality of your bunk or the size of the mess hall. This attitude exemplified American pragmatism. Italian culture valued elegance, tradition, craftsmanship. American culture valued results, efficiency, pragmatism. Neither approach was inherently superior, but in wartime conditions, pragmatism won. Elegant ships that took years to build lost to adequate ships that took months. Traditional craftsmanship lost to industrial mass production. Italy had lost the war partly because Italian culture had not adapted to industrial warfare requirements. Building beautiful ships slowly was suicide when facing an enemy building ugly ships quickly. February 9th, 1945. Allied Naval Headquarters, Rome. Fioravanzo submitted his final report on Italian shipbuilding, reconstruction. The document ran to 147 pages with detailed technical appendices. The core recommendations were straightforward. Italy must abandon riveted construction entirely and adopt welding as primary construction method. This would require importing welding equipment, establishing training programs, and completely reorganizing shipyard workflow. Italian yards must adopt prefabrication techniques observed in American facilities. This would require investment in cranes, transport equipment, and redesigned shipyard layouts. Italy must standardize ship designs to enable series production. Custom-designed vessels were economically unviable post-war. Standardization would reduce engineering costs and accelerate construction. Italian steel industry must improve quality control to produce steel suitable for welding. Current Italian steel was adequate for riveting but insufficient for critical welded structures. Italy must abandon craft-oriented training and adopt rapid skill development programs similar to American models. Traditional apprenticeships taking years were incompatible with industrial production requirements. The report concluded with cost estimates. Total investment to modernize 3 major Italian yards to American standards, approximately $30 million in 1945 currency values. Potential return: tripling production capacity with existing workforce, reducing construction time by factor of 4, reducing costs by factor of 2. The investment would pay for itself within 5 years if Italian yards could capture adequate market share in post-war merchant shipping. But the report also acknowledged political reality. Italy was defeated, occupied, economically devastated. Capital for investment did not exist. Marshall Plan aid, if it materialized, would prioritize immediate reconstruction, housing, food production, basic infrastructure. Shipyards would not be high priority. The earliest realistic timeline for major modernization was 5 to 7 years after war's end. By that time, American, British, and potentially Japanese yards would dominate global shipbuilding. Italian yards might never recover competitive position. Fioravanzo attached a personal note to the report. He wrote that he had witnessed the future of shipbuilding in California, and it did not include traditional Italian methods. Italy could either adapt completely or accept permanent irrelevance in global maritime commerce. Half measures would fail. Partial adoption of welding while retaining riveted construction would produce inefficient hybrid methods that combined disadvantages of both approaches. The choice was binary: embrace industrial modernity or remain trapped in craft traditions. The note concluded with observation that applied beyond shipbuilding. Modern warfare had demonstrated that industrial capacity determined outcomes more reliably than tactical skill or strategic brilliance. Nations that could outproduce their enemies would win regardless of other factors. Italy had lost not because Italian soldiers lacked courage or Italian generals lacked competence, but because Italian industry could not match Allied production. The lesson was universal. Future conflicts would be won by factories, not by armies. Nations that understood this would prosper. Nations that ignored it would disappear. May 8, 1945. Victory in Europe Day. Fioravanzo was in Milan when the news arrived that Germany had surrendered unconditionally. The war in Europe was over. Italian partisans had executed Mussolini 2 weeks earlier, his body displayed in a Milan square. German forces in Italy had capitulated on May 2nd. The fighting was finished, but the destruction remained everywhere. Milan had been bombed repeatedly. Industrial facilities were rubble. Transportation networks were destroyed. The economy had collapsed. Victory felt less like celebration and more like exhausted relief that the dying had finally stopped. Fioravanzo walked through the Pirelli industrial district. Factories that had produced tires, machinery, chemicals were burned shells. The Germans had stripped equipment before retreating. What they could not take, they demolished. Allied bombing had completed the destruction. Rebuilding would take years, perhaps decades. Italy had entered the war as the world's 6th largest industrial economy. It would emerge as a devastated agricultural nation dependent on foreign aid for survival. But amid the ruins, Fioravanzo saw something unexpected. Workers were clearing debris, salvaging materials, preparing to rebuild, not waiting for government directives or official plans, just beginning the work because it needed doing. The resilience impressed him. Italians had endured foreign occupation, civil war, strategic bombing, economic collapse. Yet people survived and immediately started rebuilding. Perhaps that resilience would be enough. Perhaps Italy could adapt to the industrial modernity the war had proven necessary. He thought about the welding techniques he had observed in California, the submerged arc process that joined steel plates faster than riveting, the prefabrication methods that assembled ships from modules rather than individual components, the training programs that converted inexperienced workers into productive welders in weeks. All of that knowledge was documented in reports he had written. The reports were filed in Allied headquarters, available to anyone interested. Whether Italian industrialists would read them and act on them was unknown. The challenge was not technical. The welding equipment existed, the methods were proven, the training curricula were documented. The challenge was economic and cultural. Italy lacked the capital to invest in modernization. Italian industrial culture valued craftsmanship over mass production. Italian workers trained in traditional methods would resist adopting new techniques that made their skills obsolete. Change would be difficult even with resources. Without resources, change might be impossible. August 6, 1945. News reached Italy that America had dropped an atomic bomb on Hiroshima. 3 days later, a second bomb destroyed Nagasaki. Japan surrendered on August 15th. World War II was over completely. The conflict that had killed perhaps 70 million people worldwide had finally ended. Fioravanzo, like everyone else, struggled to comprehend what atomic weapons meant. The power to destroy entire cities with single bombs changed warfare fundamentally. Everything he had learned about naval construction, about industrial production, about military logistics, might be obsolete. Future wars might be decided by nuclear weapons rather than industrial capacity. But he doubted it. Nuclear weapons were strategic terror weapons. They might determine wars between major powers, but most conflicts would remain conventional. Ships would still be needed for commerce, for trade, for transportation. Shipbuilding would still matter. The question was whether Italian yards could become competitive in the post-war world. The answer depended on choices Italian leaders would make in the coming years. November 12, 1945. Trieste. Fioravanzo returned to his home city for the first time since the armistice. The city was under Allied military administration, its final political status undetermined. Yugoslavia claimed Trieste. Italy wanted the city returned. The Allies had not decided. The uncertainty paralyzed economic activity. Nobody invested in facilities that might end up under Yugoslav control. The Cantieri Riuniti dell'Adriatico shipyard where Fioravanzo had worked before the war sat idle, partially destroyed, awaiting decisions that seemed perpetually delayed. He walked through the abandoned yard. The riveting, shops where he had spent years supervising construction, were empty. Tools scattered, windows broken. The slipways where great ships had taken shape were silent. No workers, no noise, no activity. Just ruins and memories of a shipbuilding industry that no longer existed. An older colleague, Stefano Marconi, found him there. Marconi had been chief engineer at the yard before the war. He had stayed through the German occupation, forced to work on repairs for Kriegsmarine vessels. Now he was unemployed like everyone else, waiting to see what would happen. They talked about the past, about ships they had built together, about the pride they had taken in their work. Marconi asked what Fioravanzo had learned while working with the Americans. Fioravanzo described the Richmond shipyard, the Liberty ships, the submerged arc welding, the prefabrication methods, the staggering production rates. Marconi listened silently. When Fioravanzo finished, Marconi said quietly that everything they had known was finished. The old ways, the craft traditions, the skilled riveting work that had been the foundation of their profession, all of it was obsolete. The future belonged to welders, not riveters. To industrial workers, not craftsmen. To people who valued speed over quality, quantity over elegance. Fioravanzo agreed but noted that resistance was futile. The choice was not between old methods and new methods. The choice was between new methods and no methods. If Italian yards refused to modernize, they simply would not exist. Shipowners would buy vessels from American or British or Scandinavian yards that could build faster and cheaper. Italian yards would close. Italian workers would remain unemployed. Clinging to traditional methods meant accepting extinction. Marconi understood intellectually but emotionally resisted. He had spent 40 years perfecting his craft. He could look at a riveted hull and identify individual rivet crews by the style of their work. That knowledge was valuable. It mattered. It was the accumulated expertise of a lifetime, and now it was worthless. Welding made that knowledge irrelevant. A novice welder trained in 4 weeks could produce joints superior to what skilled riveters produced through years of experience. The injustice of it bothered Marconi deeply. But Fioravanzo reminded him of the mathematics. During the war, American yards had built 2,710 Liberty ships, plus 531 Victory ships, over 3,000 merchant vessels in 4 years. Italy's entire merchant fleet before the war was perhaps 400 ships total accumulated over decades. The scale was incomprehensible, using traditional methods. Only industrial mass production could achieve such output. Traditional craftsmanship could not compete. The choice was adapt or disappear. They stood silently, looking at the idle shipyard. Neither man knew whether it would ever operate again. The political situation was uncertain. Capital was non-existent. Markets were unknown. But both understood that if the yard did reopen, it would not be the same place they had worked before the war. The riveters would be gone. Welders would replace them. The slow, careful construction methods they had practiced would be abandoned in favor of rapid assembly techniques. The profession they had known was ending. Something new was beginning, and they were too old to be part of it comfortably. March 4th, 1946. Rome. Fioravanzo attended a conference on Italian industrial reconstruction organized by the Allied Control Commission. Engineers, economists, government officials, labor representatives gathered to discuss how to rebuild Italy's devastated economy. The shipbuilding session attracted perhaps 30 people, a small fraction of the overall attendance. Shipbuilding was not priority. Food production, housing construction, electrical power generation were urgent. Shipbuilding could wait. Fioravanzo presented his recommendations from the report he had written. Adopt welding, embrace prefabrication, standardize designs, train workers rapidly, organize production industrially, invest in equipment and infrastructure. The presentation was detailed, technical, supported by data from American yards. When he finished, the questions began. How much would modernization cost? Approximately $30 million for 3 major yards. Where would that capital come from? Unknown. Marshall Plan aid might be available if America implemented the program being discussed. Private investment was unlikely given the risks. Government funding was impossible given Italy's financial situation. What about existing workers? What happens to skilled riveters? They would need retraining or find other employment. Welding required different skills. Some older workers might never adapt. This was unfortunate, but inevitable. Industries changed. Workers adapted or found other work. It was harsh but realistic. What about quality? Would welded ships be as reliable as riveted ships? Yes, if properly designed and constructed. American experience proved welded ships were adequate for purpose. Some had failed, but the failure rate was acceptably low. Quality was not the issue. Economics was the issue. Could Italian yards compete with American yards, even if they modernized? Probably not in the short term. American productivity was too high. But potentially yes in the long term, if Italian wages remained lower than American wages. Labor cost advantage might offset productivity disadvantage. The calculation was uncertain. The session ended without conclusions. The recommendations would be reviewed. Reports would be written. Politicians would make decisions eventually. Fioravanzo left the conference understanding that change would be slow. Italy was not ready to embrace industrial modernity fully. The cultural resistance was strong. The economic resources were insufficient. Transformation would take years, perhaps decades. But the alternative was permanent decline. Italian shipbuilding was already effectively dead. Without modernization, it would remain dead. The choice was not between comfortable preservation of traditional methods and disruptive adoption of new techniques. The choice was between disruption and extinction. Italy would eventually understand that. The question was whether understanding would come soon enough to matter. June 2nd, 1946. Italy held a referendum on the monarchy. Citizens voted narrowly to abolish the kingdom and establish a republic. King Victor Emmanuel III, who had presided over Mussolini's rise and Italy's disastrous war, abdicated. The Italian Republic was proclaimed. A new constitution would be written. A new government would be formed. Italy was beginning again. Fioravanzo watched these developments with interest but limited optimism. Political transformation did not guarantee economic transformation. The new republic would face the same challenges the monarchy had faced: devastated infrastructure, limited capital, damaged industrial capacity, massive unemployment, poverty. Changing the form of government did not solve material problems. Italy needed investment, resources, technology, time. Whether the Republic could provide those things remained uncertain. But there were some positive signs. American aid was beginning to flow. The Marshall Plan, formally announced in June 1947, would provide billions of dollars to rebuild European economies. Italy would receive substantial assistance. Some of that money might be available for industrial modernization, including shipyards. The question was whether Italian leaders would prioritize shipbuilding or focus resources elsewhere. Fioravanzo accepted a position with Fincantieri, the state-owned shipbuilding conglomerate being organized to consolidate Italian yards. His role was technical advisor for modernization planning. He would help evaluate which yards could be economically restored, what equipment they would need, how production should be organized. It was the work he had been preparing for since 1943 when he first observed American methods. The task was enormous. Italian shipbuilding was not just behind American practice. It was behind British practice, Scandinavian practice, potentially even Japanese practice once Japan rebuilt. The gap was measured in years, perhaps decades. Closing that gap would require sustained investment, aggressive adoption of new technologies, fundamental reorganization of how shipyards operated. There would be resistance. Workers would resist. Managers would resist. Traditionalists would insist the old methods were better. Overcoming that resistance would be as difficult as solving the technical problems. But Fioravanzo had seen the alternative. He had stood in Richmond, California, watching Liberty ships take shape in weeks. He had seen American welders join steel plates faster than Italian rivet crews could install a dozen rivets. He had calculated the productivity ratios and understood what they meant. Industrial modernity was not optional. It was necessary for survival in the post-war world. Italy could embrace it or accept irrelevance. There was no third option. 1952. 7 years after war's end, the Italian economy was recovering. Marshall Plan aid had funded reconstruction of infrastructure, factories, transportation networks. Industrial production was approaching pre-war levels. Standards of living were improving. The worst of the post-war devastation was ending. Italian shipyards were slowly modernizing. Fincantieri had invested in welding equipment. Training programs were teaching workers new skills. Some yards had adopted prefabrication techniques. The transformation was incomplete. Progress was slower than Fioravanzo had hoped, but movement was occurring. Italian yards were building ships again, not at American productivity levels, but competitively within European markets. The breakthrough was not in merchant vessels. Italian yards struggled to compete with British and Scandinavian builders in commodity cargo ships. The breakthrough was in specialized vessels, passenger liners, cruise ships, ferries, vessels where Italian design, aesthetics, and engineering sophistication provided competitive advantage. These ships could not be mass-produced using pure American methods. They required customization, attention to detail, integration of complex systems. Italian skills were valuable for such projects. The Andrea Doria, launched in 1951, exemplified this approach. A luxury passenger liner built using welding techniques but incorporating Italian design elegance. The ship represented synthesis of American industrial methods with Italian aesthetic values. It was not a mass-produced commodity. It was a sophisticated product that justified higher costs through superior quality. This was a viable competitive strategy for Italian shipbuilding, focusing on quality segments where craftsmanship still mattered. Fioravanzo watched the Andrea Doria's construction with satisfaction. The ship was welded, not riveted. The yard had used prefabricated sections for major structural elements. The production time was measured in months, not years. American techniques had been adapted to Italian requirements. The synthesis worked. Italy had found a path forward that preserved some traditional values while embracing necessary modernization. But he recognized limitations. Italy would never compete in mass production of commodity vessels. American, Japanese, and eventually Korean yards would dominate that market. Italian yards would focus on specialized segments, luxury vessels, complex government contracts, innovative designs. It was sustainable strategy but limited. Italian shipbuilding would remain small relative to global industry. This reflected broader patterns in Italian industrial development. Italy would never be a mass production economy like America. Italian industry would focus on specialized products where design, quality, and sophistication provided competitive advantage. Fashion, automobiles for affluent buyers, machinery for specific applications, specialty foods. Mass production of standardized commodities would be left to others. It was realistic strategy based on Italy's strengths and limitations. 1963. 18 years after war's end, Fioravanzo retired from Fincantieri at age 61. He had spent 2 decades working on Italian shipbuilding modernization. The industry had survived, transformed, found competitive niches. It was not what he had envisioned in 1945 when he hoped Italian yards might match American productivity. But it was adequate. Italian shipbuilding existed, employed workers, produced vessels. That was success given the starting conditions. He spent his retirement writing technical articles about shipbuilding history, the transition from riveting to welding, the industrial transformation that World War II had forced on maritime construction. The articles were published in Italian engineering journals, read by small audiences of specialists. They documented what had happened, why it mattered, what lessons could be learned. The core lesson remained what Fioravanzo had understood in Richmond in November 1943. Modern warfare was industrial warfare. Victory required production capacity more than tactical brilliance. Nations that could outproduce their enemies would win regardless of other factors. Italy had lost World War II not because Italian soldiers lacked courage or Italian engineers lacked skill, but because Italian industry could not match Allied production. The disparity was overwhelming, mathematically decisive, strategically fatal. The welding technique he had observed was symbol of that disparity. Submerged arc welding allowed one American welder to be as productive as 5 or more Italian riveters. That productivity advantage multiplied across thousands of workers meant American yards could build 10 ships in the time Italian yards built 1. When logistics determined victory, that advantage was insurmountable. Italy could not win. The outcome was determined before the shooting started by industrial capacity ratios that no amount of tactical skill could overcome. But Fioravanzo also recognized that the lesson extended beyond military applications. Industrial capacity determined economic success as fundamentally as it determined military success. Nations that produced efficiently would prosper. Nations that clung to traditional methods would decline. The choice was between uncomfortable modernization and comfortable irrelevance. Italy had chosen modernization eventually, reluctantly, incompletely. It was enough. Italy survived, recovered, found its place in the modern world, not as a dominant industrial power, but as a successful specialized economy. Adequate was sometimes sufficient. 1981. Giuseppe Fioravanzo died in Trieste at age 79. His obituary in Italian newspapers was brief. It mentioned his naval engineering career, his work on post-war reconstruction, his technical publications. It did not mention his observations of American shipbuilding methods or his reports on modernization requirements. Those contributions were buried in archives, known to specialists, irrelevant to general readers. But his son, Marco Fioravanzo, understood what his father had witnessed. Marco was a marine engineer, trained in the modern methods his father had helped introduce to Italy. Marco worked at Fincantieri, designing cruise ships using computer-aided design systems that would have astonished his father. The ships were welded, prefabricated, organized using industrial production principles. The transformation Giuseppe had advocated was complete. Italian shipbuilding was modern, competitive within its segments, successful. Marco kept his father's journals, the detailed notes from the visit to Richmond in 1943, the technical reports on welding techniques, the calculations of productivity ratios. The documents documented a moment of transition when an Italian engineer trained in 19th century methods confronted 20th century industrial reality and understood that everything had changed. The knowledge his father had brought back to Italy had mattered. It had helped transform an industry, preserve employment, maintain capabilities. The impact was not dramatic, but it was real. The journals also contained his father's reflections on what the transformation had cost. The skilled riveters who lost their profession when welding replaced their craft. The traditional methods that were abandoned not because they were wrong, but because they were slow. The aesthetic values that were sacrificed for economic efficiency. His father had mourned those losses even while recognizing their necessity. Modernity required such sacrifices. Some valuable things had to be discarded so that more valuable things could survive. 2008. The global financial crisis devastated Italian shipbuilding. Fincantieri faced bankruptcy. The Italian government intervened with financial support, restructuring plans, painful workforce reductions. The industry survived but diminished. Competition from Asian yards, particularly South Korean and Chinese builders, was overwhelming. Asian productivity exceeded European productivity, the way American productivity had exceeded Italian productivity in 1945. The cycle repeated. Industrial leadership shifted to whoever could produce most efficiently. But Italian yards retained specialized segments. Cruise ships remained Italian specialty. The design, sophistication, engineering integration, aesthetic quality that Italian yards provided commanded premium prices. Carnival Cruise Lines, Royal Caribbean, other major operators ordered vessels from Italian builders because the quality justified costs. Mass production of commodity vessels had moved to Asia. Specialized production of complex vessels remained partially in Europe. Italy adapted again. The lesson Giuseppe Fioravanzo had learned in 1943 remained relevant. Industrial capacity determined competitive success. The specifics changed. Welding replaced riveting. Computer design replaced manual drafting. Asian yards replaced American dominance. Nations and industries that produced efficiently survived. Those that did not disappeared. The choice between modernization and irrelevance was perpetual. Each generation faced it again with new technologies, new competitors, new challenges. The submerged arc welding technique that had amazed Fioravanzo in Richmond was itself obsolete by 2008. Modern shipyards used laser welding, friction stir welding, automated robotic systems. The equipment would have astonished 1943 engineers the way submerged arc welding had astonished Fioravanzo, but the principle was identical. Adopt whatever technique improved productivity. Abandon whatever method was superseded. Resist nostalgia for traditional approaches. Focus on results, not aesthetics. These principles determined success across decades, regardless of specific technologies. 2025. 80 years after World War II ended, Italian shipbuilding exists but is small. Fincantieri remains active, building cruise ships and naval vessels. Employment is perhaps 20,000 workers across all facilities, a fraction of pre-war levels. The industry is viable but not dominant. Italy imports most merchant vessels from Asian builders. This is accepted reality. Italy focuses on segments where it can compete, rather than attempting to match Asian mass production. The transformation Giuseppe Fioravanzo observed in 1943, from riveting to welding, from craft production to industrial methods, from traditional techniques to modern efficiency, was one chapter in continuing evolution. Each generation of engineers faces similar transitions, Technologies change, competitors shift, markets evolve. The requirement to adapt is constant. Industries and nations that adapt successfully survive. Those that resist change become historical footnotes. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.